What's up guys, Chris here. Today I'm going to show you how to make a reusable metal casting mold using a 3D printed part, some silicone, and some bismuth tin alloy. First we have to start with a 3D printed part. I'm going for this model of the Maltese Falcon from Thingiverse. I will post a link in the description. I'm printing in gray PLA, but I think about any filament would work as well. I could cast this as is, but I'm going to use some primer to fill in any minor layer lines. Following up with a clear top coat to seal in the primer. Next I need to build a box of some sort to hold the silicone. I'm using scrap polycarbonate just because I had some pieces laying around. Now to mix up the silicone. I'm using Alumilite High Strength 3, which is a flexible silicone with a temperature rating of almost 400 degrees Fahrenheit. I cut open the box because I forgot I had to first apply a thin layer of silicone with a brush to get the whole model coated in an attempt to try and prevent any air pockets. And in a showcase of the worst volumetric underestimation in the history of ever, I managed to come up short by a vast margin. This stuff has over a 30-minute working time though, so it was no big deal to mix up some more. The next day I can remove the mold and see what's inside. The silicone easily separates from the part, but all the nooks and crannies make removing the part a little more difficult. Now for the metal. I'm using bismuth tin 281 from rotometals.com, which is 40% bismuth, 60% tin, and melts at the incredibly low temperature of just 281 degrees Fahrenheit. This stuff is 75% as dense as lead, so it makes for very hefty, solid models. Pouring is straightforward enough. After nearly a minute, the metal begins to harden, but it's still liquid in the center. Turns out silicone is a great insulator that way. No matter though, after about half an hour I came back to see how it looks. And it's not great if I'm honest. Now I'm not one to give in at the first setback, especially when brute force could be the answer. I grabbed some pneumatic fittings and a pressure vessel to try out Plan B. Turns out the insulating properties of the silicone are really handy to keep the metal molten while I do this. Oh yeah, I didn't burn myself. Just 60 to 80 psi should do nicely. This should be crushing all those little bubbles down so small that you don't even see them. At least that's the idea. It works with epoxies. I would think it would work with metal. So we'll let that go and come back later. Works. I don't know what all those little balls are about. But then I realized what those little balls are all about. Those would have been small air bubbles in the silicone cast. You've seen how we deal with air bubbles. I may as well get some more headroom while I'm at it. Hooray! I wasn't sure how the air-filled model would react to the increased air pressure, but it looks like it did fine. Now that I have a mold that should be bubble-free, I can try again. The cast is still hot and it looks good but not great. It almost looks dry on the surface, and I think that has to do with the mold being cold when the molten metal was poured in. So I quickly did a second cast with the mold still warm from the first pour to see how that does. And it turned out beautifully. You can even clearly see the cast of the hot glue used to stick that riser to the base. Evidently, it turns out casting in silicone is just like making pancakes. The first one just never turns out quite right. You can see the difference between the two castings with nothing changed other than the mold already being warm. This also shows you why I wanted to use a silicone mold in the first place. Not only are there no seam lines like a two-part mold, but the mold is reusable over and over again. Finally, I can trim off the excess and sand the base flat. Well, I think that turned out pretty nice. Thanks again to all the patrons who helped me afford little projects like this, and as always, thanks for watching.